Hi everyone, welcome to your PlayPosit for the week. We are into lesson 3.04, so go ahead and grab your notes and we will get started. A reminder as we head into October, don't forget that our first end date is approaching. It's October 14th. So after this date, you will no longer have access to completing or retaking any graded assignments. So you want to make sure to be completing anything that has a 0. Review and retake any low grade assignments, and of course, reach out if you need any help at all. This is the same goal that we had in our live class last week. If you remember, I think it's a different picture, but we are going to continue to work towards modeling those real world linear equations. And today we are going to be graphing and writing equations. So just kind of continuing what we did last class. So as a recall, you'll have this in your notes from our time together last week, but we're going to review and I'm going to add just a little bit. So grab your notes from last class and we're going to add some information. So the first equation is slope-intercept. And I love it because the equation looks exactly how you might think. The first thing we're going to see is the slope. So we have mx, and the second thing is the intercept, that is b. So m is the slope, and b is the y-intercept. All right, standard form, we have ax plus by equals c. Not much to add for that, but point slope is something I really want to add to. So that is the y minus y1 equals m times x minus x1. So what we have in this form of a line is we have m, we have the slope, and then we also have a point. The point is x1, y1. So you can see they both have a minus, but the x1 is stuck inside the parentheses. And the equation has negatives in front, but the coordinate points do not. So let's look at an example. Let's say we had y minus 4 equals m times x plus 2. Oops, let me put an actual slope in there, like 1/2, and x plus 2. Okay, so our slope is 1/2, and our point, whenever we pull the point off of this, you do the opposite. That's what this negative is indicating for us here, the opposite. So instead of a positive 2, we're going to have a negative 2. And instead of a negative 4, we're going to have a positive 4. So you're always going to want to do the opposite sign of whatever is given to you in the equation. So let's try another one. We had y plus 1 equals negative 3 times x minus 6. The slope is negative 3, and our coordinate point is opposite of negative 6 is 6, and opposite of positive 1 is negative 1. And I can show you this on the Desmos calculator. Let's graph this one, and I will show you that the line goes through negative 2, 4. So here's our Desmos. I'm just going to type it exactly how we had it. Y minus 4 equals 1/2 x plus 2. All right, and it's supposed to go through negative 2, not through, it's a point on the line. Yes, so here we go. Negative 2 comma 4 is a point on the line. It's not the intercept, it's just a point on the line. And the slope is 1/2, up 1 over 2, up 1 over 2. We can graph the other one if you want. Y plus 1, C. 1. See how the graphing calculator is a great tool to just like reinforce what we're learning? And then x minus 6. So our coordinate point, we can even plot it here and it will show us it's going to be the opposite of negative 6 is a positive 6, and the opposite of 1 is a negative 1. And that is a point on the line, 6, negative 1. And the slope is negative 3. Down 3 over 1. Down 3 over 1. So that's going to be important when we start working with these lines. So we're going to finish up the notes from last class. I promised we would do that. This says to write it in standard form. So remember, this is standard form. So we're trying to get this to look like that. So all you're doing is rearranging the equation. So we want the x and the y term on the left-hand side. So let's move the x term. Just going to move it over, and you end up with negative 3x plus y equals 7. And look, that's it. We have the x term, the y term, and then just the number on the right-hand side. That's it. Let's try another one. Our goal is to get it to look like this. It's always nice to have the goal in mind. So we need the x term and the y term on the left-hand side. Well, here we have a parentheses. Remember, whenever you see a parentheses, we want to distribute. So we got to do that first. 8 times x is 8x. And 8 times negative 4, what's that? Negative 32? Okay, now we need our x term over here. So we'll just do the opposite of positive 8. And this is kind of funny because when you look on the left-hand side, there's nothing that it can combine with. And that's okay. We're just going to write it. We're just rearranging. We're like sorting out the terms. And now we need the 50 over here, the negative 50. So we got the x term, negative 8x, the y term, and just the number, just the constant. That's 18. There we go. Next one, write an equation in point-slope form. Okay, so from your notes, here is the point-slope form of a line. So we just need to plug in the information we're given. We have the slope, that's m, and we have a point, x1, y1. Okay, so we're going to have y minus 4 equals m, that's 2, times x minus 3. That's it. Look, we have our slope that they gave us, and we have the coordinate point. And you could always check yourself. Like this is minus 3, so when you pull it out, it is a positive 3. It's the opposite. This is negative 4, so when you pull it out, it is a positive 4. Let's try this one. Here's the goal. So we have our m, we have our x sub 1 and y sub 1. So y sub 1 is a negative 2. Remember, it needs to be the opposite, so we're going to make that positive. M is 1/5. X, and then our x sub 1 is a negative 4. It needs to be opposite. So it needs to be opposite in both directions. So if you're given the point, you're going to have the opposite sign. And you can always check yourself. Like if I was going to pull off the information from here, I'd say, oh, there's m, and here's x sub 1. But remember, it's got to be opposite. So instead of a positive, it's a negative. And sure enough, that matches. Instead of a positive 2, it's a negative 2. And that does match. Okay, let's do this. We got this. We're going to do some more examples with forms of lines. This raccoon, sorry. Okay. It says we're going to write an equation of a line that passes through these points. Show all 3 forms. So we're given 2 points, and we need to show all 3 forms. This one, slope-intercept, standard, and point-slope. And so we only have 2 points. Well, we know for sure, at least in the first and the third, we're going to need m, right? We're going to need the slope. So we might as well find the slope first. Remember, slope is the change in y over the change in x. And we can definitely find that with these 2 points. So we can label this x sub 1, y sub 1, x sub 2, y sub 2, and plug it in. So y sub 2 is negative 3 minus y sub 1 is 0. X sub 2 is 0 minus x sub 1 is negative 3. Be careful. Okay, the top, negative 3 minus 0, that's just negative 3. And down here, a negative times a negative is a positive. So you end up with negative 1. So our slope is negative 1. We're going to need that, right? Well, now that we have a slope and a point, which one can we do first? Point slope. Let's do it. So point slope form, we'll do it over here. We just got to plug it in, right? We have a point. You can pick any of these points you want. We know the line goes through both of them, so you can pick either one. So I'll just pick the first one. Y sub 1 is 0. M we found is -1. And x sub 1 is -3. Remember, we want it to be opposite, so we'll make it a +3. That's it. You can leave it like this, or you could certainly write it like this. That's accurate because we don't usually write 0, right? All right, there's our point slope form. That's done. Now we can use this, use this to write the other two. So let's do a slope intercept. And we'll start with the form of the line that we already have. And we just got to make it look like this. It's really close, right? But it does have parentheses. So let's distribute so we can get rid of our parentheses. And you get y equals -1 times x and -1 times 3. There it is. That is our slope intercept form. We have a slope, -1, and we have an intercept, -3. Remember the y-intercept is when x is 0? Look, it actually gave us the y-intercept also. We could have used that right there. And lastly, our standard form. You could take any of these and make it look like that. Let's just start with this. Remember, we want the x and the y term together, so I'm going to add 1x to both sides. And you get x plus y equals -3. That's it. Something that's really cool is we can actually graph all three of these and just double check our work because they should all match, right? So if we go to Desmos, close these out, and I'm going to put in all three forms of the line that we found. Y equals -1x minus 3. There's our slope intercept. Y equals -1 times x plus 3. Here's our point slope form. And the last one, our standard form, x plus y equals -3. Wow, check it out. It's the same line. You can turn them off. Look, so the first line is green, and then the second one graphs right on top of it, and the third one. So we can confirm our work. They're the same line. Here's our next example. Graph this line using the slope and the y-intercept. So if you did take Math 8 last year, then you likely covered this. You did, but some of us did not take Math 8, so I wanted to make sure to go over this. This is in the y equals mx plus b form, right? So the slope is 1/7, and the y-intercept is 3. All you need is those two pieces of information and you can graph this line by hand. It says select the points on the graph. So let's start with the y-intercept. We know the line is going to go through 3 on the y-axis because that's what it is. That's the intercept, right? And then we'll use the slope to plot the rest of the points. Remember, you can think of slope as rise over run. So we can start here. We can go up 1 and over 7. There we go. Up 1 and you can continue to go over 7. To get the other point, I can go down 1 and over 7. And we will connect those dots. Now, see if I can freehand this decently. There we go. Okay. And one good quick check is you can see the slope is positive, right? So if you were standing on this line from left to right, you would walk up the line. It is pretty flat, but it is still a positive slope. You can always plug this in the calculator to double check. Now this wants us to graph using intercepts. Remember, our intercepts happen where the other one equals 0. So to find the x-intercept, we want to set y equal to 0. So let's just plug in 0 for y, and we'll see what's x. So 9 times 0 is 0, and look, you get x equals -9. Done. To find the y-intercept, that's when we set x equal to 0. So we'll put 0 in for x and solve for y. So this is -9 times y. The opposite is division, and you get a +1. So now we have 2 points. We can always graph a line with 2 points, right? X is -9, so that's right here on the x-axis, and y is 1. This is another very flat line. Ooh, that's a pretty good line. And again, you can always put this into your graphing calculator to double check. Let's do it. X minus 9y equals -9. There it is. Nice and flat. 0, 1, and -9, 0. Here's one. It says a line with a slope of 9 passes through the point 3, 5. What is an equation in point slope form? So we have a point, x sub 1, y sub 1, and we have a slope, and it wants point slope form. So grabbing your notes, right? Our goal is this. This is our point slope form because we have a point and a slope. So once you have that written out, you can really just plug it in, right? M is 9. X1 is 3. We're going to do the opposite. So we want -3. And Y1 is 5. And we're going to do the opposite. So we want -5. Always double check yourself. If you were to have this graph and you were to pull off the point, -3, opposite of -3 is a +3. Opposite of -5 is a +5. So that's it. Graph this function. Select the points on the graph. Okay, this is where you just like have some freedom. You can graph this function however you want to. Some people might even make like a little XY chart and plug in points. Some people might use their calculator straight off the bat. Some people might recognize, hey, this is point slope form. I'm going to grab the slope and I'm going to grab the point. Any of those will work. Let's do the point slope form since that's what we're looking at here. So here's the slope, 7/3, and the point is going to be the x value, but opposite, so +2, and the y value, but opposite, so -6. Now we can definitely graph this line. We're going to put a point at 2, -6 over 2, down 6. And then starting from that point, we will use the slope. We'll go up 7 over 3. This is a much steeper line than the other ones we've been doing. There we go. And we can always put this in the Desmos and confirm our work. Next up, look at this graph. Well, we're going to go opposite now. What is the equation of this line in point slope form? So we need a point and we need a slope. We need a point and we need a slope. So it told us right there, point slope form. So it gives your brain that clue what you're looking for. You're looking for a point and you're looking for the slope. You need those two things to give us the equation. And this one says specifically to use the red point in our equation. So we're going to use that red point as the point. So remember we start at 0 and we're going to go over to -5. That's our x value. And we'll go down to 1. That's our y value. So there's our point. Now we need the slope. So you can get the slope from the graph, right? So we can go, we want to start at one point and get to another. So we want to find another point that like goes through a grid mark, right? We wouldn't want to use this one. We could use this one. Or it looks like this one, or this one. Anything that is on that grid. So we could go up 1 over 3, up 1 over 3, up 1 over 3. So it's 1 over 3. There's our slope. So just like the other examples, once you have these two pieces of information, x1, y1, we can plug it in. So remember our slope goes here, so we would do 1/3. Our x coordinate is a -5, but we want the opposite. Well, they already have a minus here, those tricky. So if it's a -5, then this would have to be -5 right here, right? That's so tricky. Be careful because they already have the minus in there. And you could always test it, right? So the negative times the negative is a positive. And then when you pull it out, this will be a -5, which is what we have and what we want. And then the y is a +1, so that one is more simple because it's minus, and the opposite of minus is positive. All right, which equation represents the line that passes through these points? So again, we have some methods. Whatever your brain sees first, you can go straight to the calc. You can graph these and see which line passes through these two. That would take a long time. I know you could use the calculator and it would be helpful, but that would take a long time. We could write the equation of the line. That might even take longer. Not longer, but I think what I'm trying to say is I have a shorter way if you're interested. We have 2 points, right? And we know all of these have a slope in them. They're all in the slope-intercept form. So we need to find the slope. Once we find the slope, that might guide us in a direction, right? So let's find the slope first. x1, y1, x2, y2. I'm going to subtract the y's and subtract the x's. So the first y, -2 minus 4, and 8 minus -4. Keep change flip. On the top, you have -6. Keep change flip. And we have 12 on the bottom. Now this does reduce, right, to -1/2. So our slope is -1/2. So if you look, we can automatically cancel out A and B because those have a slope of -2. Okay, now we need to know, we really need to know the y-intercept. So what if, so we have this form, y equals mx plus b, right? And we know the slope is -1/2, so I'll plug that in. But we don't know b. We're trying to find b. But look, we have an x and a y here. We could use one of these x and y points to solve for b. Let's try it. We could use -4, 4. So let's plug in -4, 4 for x and y. So y is 4, x is -4. Now look, we only have one variable. We can solve for b now. Get b by itself. So -1/2 of -4, that's a +2, right? You could do -1 times 4, you get 4 over 2, which is 2, plus b. To get b by itself, we'll subtract 2 from both sides. Check it out. B is 2. So the slope is -1/2 and b is 2. That matches C. Oh, another way you could even solve this, again, this would take a while. You could take this x and this y and plug it into every single one of these and make sure that the equation is true. You could do that. All right, our last example, look at this graph. Write the equation of the line. What do we know about horizontal lines? We know there's horizontal lines have what kind of slopes? They have a slope of 0. Again, if you're standing on this line, you're not going to walk up, you're not going to walk down. You're going to walk at that constant rate all the way across it. So they do have a slope of 0. And look, it's going through the y value of 9 for everything, right? When x is 2, y is 9. When x is 6, y is 9. When x is -8, y is 9. So if you were to make like an old school XY chart, no matter what x is, guess what? Y is 9. That's the definition of a constant equation. So y is 9. So you just said it. Y is 9. That's the equation of the line. Because the slope, excuse me, the slope is 0. So you could write it like this if you wanted to. See, we have the slope and we have the y-intercept. And I'll show you over here. You don't believe me. Y equals 9. And of course, I have to zoom out a little bit. There it is. That's our graph. Y is 9 always. So when you're writing horizontal graphs of lines, it's just whatever it is. Like if the line goes through 4 or 3, then the equation of this line is y equals 3. If the line goes through -2, the equation of this line is y equals -2, because it's always going to be that. And guess what? The cool thing is it happens for x also. So if you have a vertical line and it's going through x equals 5, the equation is x equals 5. If you have a line going through -6, guess what? The equation is x equals -6, because x is always -6, or x is always 5. All right, thanks for sticking with me for those examples. I'm going to put this link in your PlayPosit if you would like some more practice on this topic. I look forward to seeing you all this week, and continue to reach out if you need anything. We will have some math open office hours. With Miss Gilner. Don't forget about those. They are on your plan. And if I remember correctly, hold on, I'm going to look. Okay, I found it. They are Tuesday at 3:30. Tuesdays at 3:30. So every Tuesday at 3:30, you will see open office hours on your schedule. You can click into. If you would like to send me or Miss Gilner like ahead of time what you want to work on, you're welcome to do that. Otherwise, you can just ask her right in that session. And then on Wednesdays at 12, we have an extra targeted support with me. And those students change week to week, just depending on kind of how we're working that week. But if you ever want to be included in that and you don't see it on your schedule, let me know and I will happily add you. All right, everyone. See you soon.